In this presentation, I will outline the basic function and construction principles of a grid. A firm understanding of grid construction will aid in making smart decisions when and how to use a grid to achieve optimal results. Before we begin, let's take a moment to define some of the radiation terminology I will use in this presentation. As in all radiographic setups, we start with an X-ray tube positioned at a standard distance above the X-ray table and patient. Next comes the patient or object being radiographed, centered below the tube. Finally, we have an image receptor positioned below the patient. The primary radiation exits the tube. Notice that the radiation beam is reduced in the area below the patient. This is due to some of the primary rays being absorbed in the patient's tissues. This primary radiation that exits the patient is called remnant radiation. It carries the shadows of the patient's bones onto the image receptor. There is a second form of radiation exiting the patient. This is called scatter or secondary radiation. Scatter is caused when primary radiation interacts with the patient's atoms and randomly changes direction. Scatter carries no information regarding patient tissue composition and structure, and it impedes visualization of the part being examined. Fog will be present in all radiographic images. Fog becomes objectionable when the part being radiographed is thicker than about 10 centimeters. In an adult patient, this threshold is passed at about the thickness of the shoulder or a knee in the lower extremity. Fog is produced primarily by scatter radiation, which is radiation that is redirected by the atoms in the patient's tissues. When the primary radiation is scattered, it no longer can outline the shape of the patient's tissues. It serves to interfere with visualization of those structures. Fog reduces contrast resolution and interferes with recording and visibility of small or low contrast structures. It is important to note that scatter originates in the patient's tissues. Since the patient is located close to the imaging plate, a large portion of the scatter tends to travel at a low angle to the image receptor. The basic construction of a grid is very simple, but must be machined to exacting tolerances to avoid interfering with the radiographic image. The grid was invented by Dr. Gustav Bucke in 1914. We will start with our construction of it with a thin strip of what's called interspace material. This material must be radiolucent. Radiolucent materials allow X-rays to penetrate without stopping their passage. This is like glass, which allows light to pass through it unimpeded. Aluminum, plastic fiber, or paper are materials that are used to meet this requirement. Next comes a thin lead strip, which is glued to the interspace material. Now we add another layer of interspace material, and another layer of lead strip is glued onto the interspacer. To finish the interior of the grid, we alternate successive layers of interspace and lead strips until we have a structure that can span the length of an imaging plate, usually about 17 inches. To finish the grid, a thin layer of aluminum sheet is wrapped around the grid to protect it and to provide stability. Finally, a line is printed on the surface of the grid to indicate the center of the grid and the direction of the lead strips within the grid. Knowing this characteristic will guide decisions on how the tube can be angled without causing grid cutoff. Here we have our patient X-ray tube and image receptor setup. The grid is positioned between the patient and the image receptor. The function of the grid is to remove scatter radiation while allowing information-carrying remnant radiation to reach the image receptor. This removes fog or noise from the final image, improving contrast resolution. Notice how the primary and remnant radiation travels in an orderly fashion at a high angle to the image receptor. This orderly pattern allows the rays to find the spaces between the lead strips and form an image on the plate. On the other hand, scatter radiation is more random and is produced in the patient's tissues close to the image receptor. Being produced close to the image receptor means that most scatter rays travel at a low angle to the grid and therefore interact with the lead strips. The lead absorbs most of the scatter. To understand how a grid functions, it's important to understand how a grid is constructed. First, we have the interspace material, which is radiolucent and allows the passage of X-rays. Plastic fiber is one material of choice. Aluminum is another. Some manufacturers use wood or paper as an interspace. Wood and paper interspacers have the disadvantage of warping if they become wet. Lead is the functional element of the grid and it absorbs the scatter radiation. An aluminum cover is added to protect the grid and support its structure. And finally, a stripe is added to the cover to indicate the orientation of the lead strips so a radiographer can make proper angling decisions that will not cause grid cutoff. The main purpose of the grid is to remove or reduce scatter radiation that is caused by thicker body parts. Reduction of scatter causes an increase in contrast resolution on the final image. The grid is positioned between the patient and the image receptor. Scatter radiation is produced by the interaction of the primary beam with the electrons in the atoms of the patient's tissues. The primary and remnant radiation travels in an orderly fashion and the grid strips are arranged to allow them to pass. Whereas scatter is random in its production and direction, and generally travels at a low angle relative to the grid. Most is absorbed by the lead strips of the grid. The main purpose of a grid is to reduce fog on the final image. The benefit of fog reduction is that small or low subject contrast structures are more likely to be recorded and displayed as part of the final image. To put a grid's benefit in terms that a computer technician would understand, grids increase the signal-to-noise ratio. More signal or information, less noise or fog. The use of a grid will increase MAS by a factor of 2 to 5 times the original, which explains why grids are only used for thicker patient parts. Improper use of a grid can cause exposure errors that demand repeat images. I will summarize these errors and how to prevent them in a future presentation. Grids are precision structures and are expensive. A grid can easily be comprised of about 1,751 to 2,550 thin lead strips to make its body. Also, grids are easily damaged if dropped. Many of the grids you will use are fixed and built in as part of the table or upright bucky system. Thank you for your kind attention. This will end my presentation on the basic elements of a grid.